Hey, biology, let's look at that quiz we just took. So you'll be, oh, hello, kitty. So you'll be ready for the test tomorrow. Okay, so in this quiz, the very first thing you had to do was you had to go down and fill in the taxa for all of these animals. And so I like to remember, did King Philip come over for good spaghetti? And then you can go back in and see, okay, so that means this is domain. This is kingdom. This is phylum. This is class. If these were, interestingly, if these were plants don't go under phyla. They have something called a division. Class, order, family, genus, and species. Done. Easy peasy, easy 2 points. Now let's draw a phylogenetic tree for the species listed in this table. So you could do it a couple different ways. I like to do mine this way, where we start with all of life down at the bottom. Okay, so whatever we consider living or non-living would be below this. Viruses might be below this. And then we would say, okay, cool. All of these animals are eukaryotes. Eukarya. All of these animals are in Animalia. So domain, Animalia. Kingdom, the phylum is Chordata. All of these animals are mammals. Mammalia. All of these animals are, oh wait, there's a difference. So once we get to the order, we see that while most of them are in Carnivora, we do have one that is instead is Lagomorpha. Lagomorpha. And that is, we could keep going and say, okay, if that's a family this way, I mean, family would order. Then the family name would be Leporidae. And then the genus is, how do we say this? Thank you, Latin. Oh, R-Y. Dolagus. And remember, that's a genus, so it needs to be underlined. And then finally, the species is O. cuniculus, or the rabbit. Okay, the common rabbit. And again, the genus and the species need to be underlined because we do not write in italics, okay? We don't do it. Okay, moving on. So that was the order. Let's talk about family. So if we had gone this way, we would have gone to the rabbits or the lagomorphs. If we continue in carnivora, we see two different things. We see Felidae and Ursidae. So I'm going to have something going off this way for Felidae. And I'm going to keep going this way for Ursidae. Okay, so we see that the felids split into, they both are Felis. And then they split into Felis Leo and Felis Tigris. Again, underline, underline. Okay, cool. Underline, genus. Awesome. Now, what do we have left? We're in Ursidae, the family of Ursidae. Now let's go to the genus. Oh, there's two genuses. We have a genus that is Aleuropoda. And then we have, so underline that. And then we have the genus Ursus. Cool. Underline, underline. And then we go into the species. Aleuropoda is Aleuropoda melanoluca, which is Latin for black and white. That's the panda. And then we have Ursus arctos. Arctos, which is the brown bear. Done. That's your phylogenetic tree. So make sure if you have 5 species here, you better have 5 points to your tree. Do we? 1, 2, 3, 4, 5. Okay? And remember, you're basically saying, I need to make a line for each one of these, each one of these, each one of these. So if I were to follow this roadmap, I will eventually find each one of the species. So if I follow this roadmap, I turn here, I get to the rabbit. Follow this roadmap, I get here, I get to the cats. I either get to Tigris or Leo. If I keep going in the other direction, if I keep going this way, I get to the brown bear or the panda. All right, cool. And also note that you could have flipped and done the cats going up this way and the bears going this way, or you could have flipped Leo and Tigris, or you could have flipped Arctos and Melanoluca, and you still would have gotten the same thing. Each one of these points is a pivot point. Okay, awesome. Keep moving on. So we're talking about these rabbits. A breed of common rabbit have long, soft fur, like sheep, are often raised by humans who spin the fur into yarn. Is this a product of natural or artificial selection? So if you had given really good proof for this being natural selection, then we would have given it to you. But technically the answer is artificial selection. Oh my goodness, I'm over artificial selection. And the thing is that these rabbits naturally have some soft fur. that the humans then bred out. So humans bred out long, soft fur in these animals. So we picked something that we really liked, and then we kept breeding it over and over and over until we got longer and softer and longer and softer hair. Okay? Explain. Let's see, what else could you say other than this? Artificial selections, humans bred it out. Not seen. This is not what you see in the wild. In wild, basically, anytime humans are involved with the reproduction of another animal, in that they are causing the breeding to go a very specific way that the animals are not in charge of, then that is artificial selection. Okay, let's talk about what is one distinguishing trait of the group Animalia, and talk about how does this make something an animal and not something else. So Animalia. They are heterotrophic. They are multicellular. And they are internal digesters. Okay, so that is different from the fungi. So fungi are heterotrophic. And they are multicellular. But they are decomposers. Okay, so they are external digesters. Okay, so they excrete digestive juices that then digest stuff outside their bodies, and they soak the rest up. So Animalia is distinguished from fungi by this factor, but Animalia is distinguished from the plants, from Plantae, by being heterotrophic. Autotrophic. So plants are autotrophic, animals and fungi are heterotrophic. Plants are multicellular. That's really all you need to know there. And the reason why I'm making the point of the multicellularity is that the protists are single-celled. They're a weird group. They're single-celled. They can be autotrophic or heterotrophic, depending on which species you're looking at. They could be either one. All right, cool. So you had to put one of these. You had to say something about animals that distinguishes them from the other groups. On the test, you're going to have to be much more specific than just saying animals are heterotrophic and plants are autotrophic. Because just being autotrophic doesn't distinguish animals from protists. Or just being heterotrophic doesn't what did I say? Animals being heterotrophic does not distinguish them from fungi or some of the protists. Animals being multicellular doesn't distinguish them from fungus or from plants. But the fact that animals have all three of these distinguishes them from all the other kingdoms. All right, last question. So this was kind of a dense question, but you had to go in and say, what is happening? And we define things by what they have, unless they have lost it over time. So mosses have simple leaves. They do not have seeds, vascular tissue, or flowers. Okay, so we can put in here simple leaves. You can put it even here, okay? Simple leaves. Maybe you don't put anything there. They do not have seeds, vascular tissue, or flowers. Ferns have no seeds or flowers, but they have vascular tissues. So ferns have simple leaves and vascular tissues. Oh, but so does everything else. Okay, so if we were to go, so this is the thing. Remember, whatever you put above this has to apply to everything that comes below it. So if angiosperms have vascular tissue, seeds, and flowers, and their seeds can be simple or divided, they have four things, but what do they have that is different from a gymnosperm? Gymnosperms have seeds, vascular tissue, and no flowers, so flowers must have happened here, because gymnosperms don't have flowers. But how do we distinguish these two from the other two? Gymnosperms have seeds, ferns have no seeds, okay, so seeds must have happened here. And then vascular tissue happened here. Tissue. So some people I saw were really good, and they made this little chart where they said mosses, ferns, gymnosperms, and angiosperms. Okay, and then they went and they were like, well, who has what? Let me organize this so I can figure this out. So they said, okay, leaves, vascular tissue, seeds, and flowers. And then by doing that, they saw that you could organize this nicely. Mosses have leaves. They don't have anything else. Ferns have leaves and vascular tissue. Gymnosperms have those. Angiosperms have all of these. And that's how they made this chart. And it was beautiful and fabulous. But you had to notice that angiosperms also, sometimes you could say here, leaves can be divided or simple. Or simple. Okay? Whereas these are simple leaves. These leaves could be divided. Okay, leaves divided. These are divided leaves. And then we see that, oh, look, we have simple leaves here and we have some simple leaves here. That's going to be a key in a second. Okay, give an example of homologous trait found in at least 2 groups of land plants. And we know it's homologous. So we could look at, you could look at anything where 2 things are closely related and have something. So seeds are homologous in the gymnosperms and the angiosperms. Okay, so they both have it and they're closely related. You could even do ferns and gymnosperms both have vascular tissue. Ferns and angiosperms have vascular tissue. They all have leaves of some sort, something like that. Okay, how do you know it's homologous? They're closely related. They both have this trait. We don't know how they use them, but we know they both have them. And remember, in homology, we like to think about how they use them, but this is good enough. So this was a tricky one to catch, and it took me a while even to see this, but the analogous trait found in 2 groups was the simple leaves. Okay, so the simple leaves are seen only in the mosses and the angiosperms. These are not closely related, according to our tree. Even though it's only 4 things, and if you don't know what any of these things are, you might think they're really closely related, but it's far enough away. It's the only things where they're farthest. These 2 things are the furthest away in relationship because it takes so many branches to get there. So the fact that you see simple leaves in mosses, not in ferns, not in gymnosperms, but then you do see it in some angiosperms, means that it is analogous. And then all the traits described have helped plants adapt to dry land. Choose one and explain how it would have been favored. So you had to explain how it was favored. So one is vascular tissue. So if you picked vascular tissue, this brings water up from ground. Okay, you could have picked seeds. Seeds help disperse the next generation. But you couldn't just say that because you can disperse anything in water too, okay? So you had to go do something else like someone put by falling to the ground. Okay, that's different from in the water, okay? What else do we have? We have vascular, we have some leaves. No one really talked about the leaves, but leaves have cuticles, waxy cuticles, to prevent water loss. So that was an answer as well. Okay, I hope this all helps. Another video is coming soon with some more stuff for the test.